All right, good morning. So today we're going to start talking about scatter plots. And literally scatter plots, it's basically a graph with a bunch of dots that are not connected. So there's discrete data. And the whole point of this standard is we're trying to create a function that can model this data, okay? All right, so a scatter plot is always going to be in your X and Y. Okay? All right, so you have the x-axis and the y-axis. Scatter plots are usually called correlations because we're trying to see how they're related to a particular event, okay? Between the two variables, and the correlation coefficient describes how well a line fits that data, okay? A trend line can be drawn for this. So when I look at this line right here, this correlation plot, I can kind of see it having a positive linear growth. All right? So maybe something like this. Okay? So this red one would be the best fit line. Okay. Now, the best fit line is a way of predicting what the data, or more or less what the value would be. So for example, if this is 1, then that's 2. When x equals 2, let me zoom in a little bit. When x equals 2, the function gives us this point right here. But the actual data point is a little bit off. See? So there's a little, it doesn't quite fit it perfectly. That's why it's known as a best fit line. All right. Second period, can we please stop talking and start focusing on the lesson? Thank you. So this one, we would say that it has a positive correlation. Positive slope, positive correlation. It's very simple. And the trend for this one is as the x value increases, the y value increases. Okay. Our correlation coefficient would be very close to 1. All right. Because the data points, the scatter data is not everywhere. It's very close to the line. All right, so we know that our correlation coefficient is going to be close to 1. 1 is perfect fit. And of course, I already mentioned a positive slope. It's going up, right? It's the rise over run business. Now, we call negative correlation when we have a negative slope. Okay, so this right here, if I were to draw a line of best fit, it would be the line coming down like this. All right, and it's supposed to be a straight line. Got it? Please take the AirPods out, please, Christopher. Nolan, take them out. All right, now because it's a negative slope, the correlation coefficient is going to be very close to 1. Willem, can you please not have a conversation in the middle of lesson? All right, so as x increases, the y value decreases. Negative slope. Once again, positive slope is going to have a correlation coefficient close to positive 1, and a negative correlation is going to have a correlation coefficient that is close to Wait, I think I said something wrong. A positive correlation will have a correlation coefficient close to positive 1, and a negative correlation is going to have the correlation coefficient that is close to negative 1. All right, which makes sense. Positive slope, positive value, negative slope, negative value. Now, it is possible that there is no line that's going to give you the best fit. As you can see, these are everywhere, and there isn't a line that we can draw that we can say that all the points are close to.
I'll sort of squint my eyes, see if it forms a shape or a line. That one doesn't.
All right, so there is no relationship. Okay, no correlation means no relationship. I meant to grab the highlighter. Okay. There is no relationship between X and Y. And the correlation coefficient would be closer to 0. And when we say close to 0, something like 0.08. Okay, not exactly 0, but close to 0. And basically you have no line, so it's not even about a zero slope or anything like that. It's just there is no line. Oh, FYI, your line can also be horizontal. And it can also be vertical. Are we clear? So the whole point is how close is the data to that line? Right? Okay. All right, so here are some examples of correlation coefficients. So please pay close attention. This column right here is going to be for the positive ones. If you have a value between 0.7 to 1, then you're going to be considered strong positive because those are the numbers that are closest to 1. If you are between 0.3 to 0.69, then you're going to be considered to be moderate positive. A medium, And if you're 0 to 0.29, you're usually considered to have none or a weak positive link. Okay? Any questions on that? So how would you classify a number like this one? I'm gonna put a letter on this so it's a little bit easier to get your participation. All right, so I'm gonna call this one A, this one B, and this one C. All right, and here are some just quick checks in class just to see if you understand how to classify it. If your correlation coefficient is equal to 0.63, how do you classify? A, B, or C? All right, so 0.63 would be between 0.30 and 0.69, so we would classify it as moderate positive. Clear? All right, so let's say that the number was 0.23. How would you classify it? C, which is weak positive. But what if it was, instead of 0.23, it was 0.03? How would you classify it? It's still C, weak positive, or almost even close to no correlation. Are we clear? All right, so this is a range. The closer you are to 0, the more we say that you have no correlation, that you're not related to any of the points. Nothing can fit you to a line. And this one, you can kind of get a line, but they're really off. Like it would look something like this. Really far away from your best fit line. But there is a sort of pattern there, okay? So that would be a weak correlation. All right. Maybe that will help if we draw a little image to kind of get an idea of what we're talking about. So here on the side, all right, so when we say a strong correlation, we mean that the dots are close. Please draw they're close to your best fit line. Mm-hmm. If you have a moderate, and then you have more distance between the points. Some are close and some are not so close, okay? All right. And then for this one, the points are just all over the place. There's nothing you can do. So there is no correlation. Or you could say a weak correlation, right? Like you can kind of play it off and be like, oh, isn't that just a line going through here? Yeah, it could be, but it could not, maybe. So. Okay. All right, do you have the 3 diagrams? All right. Do you still need me to keep this up for you guys to get the diagrams? I'm sorry? We're doing notes. We're taking a test right now.
You can go. Are we taking a test today? I heard test, I'm heard how.
I'm just asking, do you need more time to get this on your notes? All right, so now this one. Strong negative is going to be when your value is, now notice that the values are the same. Your coefficients are always going to be, these are going to be negatives. Okay, so make sure you put your negative signs. All right, so that'll give you strong negative. This range will give you moderate negative. Oh, actually, 0 can't be positive or negative. And that we would consider to weak negative, okay? And it's the same deal, except that now you have a negative slope. Your best fit line, a good one would be like this. A moderate one, you would have a lot more distance in the points, you know. And then no pattern would be this, okay? They're just everywhere. I mean, but somebody can be like, well, there's a line going through here. Yeah, but the points are really far away, so it's not a good correlation. Any questions on that? Are we okay? Now, if you would take a moment and determine, it says determine if the following graphs have a positive, negative, or no correlations. Then, after you make your decision, determine if it's strong, moderate, or weak, positive, or strong, moderate, or weak, negative. All right, go. Let's go ahead and start on whether it's positive, negative, or no correlation first, okay? No, letter A. No correlation, right? All right. All right, B, what is the second one is none. Okay, just slow it down just a bit. And for letter C, what would you say? It's positive. And would we say that it is strong, moderate, or weak? Okay. All right, letter D. Is it positive, negative, or no? Yes, I will agree with Vincus. It is a positive correlation, but it's very moderate, as in medium, not very strong.
This first one was going to the left side.
Once again, it's line of best fit, not perfect fit, okay? Some of the points are going to be above it. Some of the points are going to be below it. Remember the diagrams that we drew? Okay. All right, and the last one, is it positive, negative, or?
Negative.
All right, so it is a negative correlation, and it is strong. Okay, good job. All right, so now is where we're interpreting the data. Okay. All right, so this is, if we read what it says, please. It says the relationship, I thought I grabbed the highlighter. Relationship between the number of days since the sunflower seed was planted and the height of the plant. So the x-axis is what? What about time? All right, once again, let's go ahead and read. It says the relationship between the number of days since the sunflower seed was planted. So this is the days since you planted the sunflower. What do we have on the y-axis? Height of what? Height of what? Anybody? Thank you. The height of the sunflower plant. Okay. And it's going to be the same for all three of these graphs. Now, when we focus on this one, how do we interpret this? What information is this telling us regarding the number of days since we planted the sunflower plant and the height of the sunflower plant? Okay, what is the first graph telling you? It's what? But what does negative imply regarding the sunflower plant? Okay, what does going down imply regarding the storyline that we're using of a sunflower plant? Okay. You guys are describing just the correlation. We're talking about context. What is happening to the sunflower plant? Uh-huh. Let me listen. Okay. Okay, what's happening to the height of the sunflower plant? Okay, so now, okay, so what would cause a sunflower plant to have a slight decrease in height as the days go by? Tell me the story. What is going on? Yeah, it's telling you that you're not taking care of the plant well enough. The plant might be slowly dying since it's losing height. Clear? That's what this is telling you. Yes, it's negative correlation. But then when the negative correlation, what does that mean? That means that as the days go by, the plant is not growing. It's actually losing height, which means it's probably missing nutrients. All right, so do you understand how we go from just a general classification of the data versus the interpretation of the context? Yes? All right, so what can you tell me about the sunflower plant based upon this graph? Well, tell me more, come on. Okay, how do you know? Talk about the slope. Talk about the slope of the line. Because this is an increasing slope as well. Isn't it? Isn't this line an increasing slope? Okay, so how does that compare to the actual line of best fit for this one? Uh-huh. Yes, but describe how is it increasing? Weak, moderate, or strongly? But don't get upset. Okay, Vinquist, we've had this conversation already in the way you respond, okay? Thank you. Now, what I want to hear from you guys is, yeah, the plant is growing very fast. Okay? It's a high slope, it's growing really fast and very constant. Versus just growing, which could be slow growth, okay? It seems like this plant is flourishing. Okay? All right, so now compared to graph C, what can you say?
It's increasing still, but it's coming down. The height going down.
Where is the height going down?
It's going up, big fella.
Where is it going up?
You like going up, me like going up to 7, bro. You know the 70 right there?
Okay. Okay. Okay, guys, shh. If we cannot keep it focused without being derisive towards our peers, without making jokes, then I'm not going to ask you questions and incorporate you into the lesson because you take it completely off track. Are we clear? Please make sure that you're listening and paying attention and taking your notes, okay? All right, yes, this one has positive growth. It's almost a very similar slope, but it's rising just a little bit slower. But this one is, I think, a better, more consistent growth. You see, when I put the line there, all the points are closer to it. Whereas this one, you have some growth, then you have some no growth, and then there's growth, then it kind of slows down a little bit. Whereas this one is way more consistent, okay? So here you're taking care of the plant, but you might miss a day or two, whereas here it seems to be on a regular schedule. So what we did just now was not just looking at the data and what is the data telling us? How do we interpret the data? Are we clear? And this is what we do in government, in schools, in every single business. You look at your records, you see what type of correlation you have, and then you try to decipher what's causing it. Right? Why are we making money? What is selling? Why aren't we making money? What isn't selling? What can we do to fix it, type of thing, right? So being able to interpret data is a critical skill. All right. So now in this example, we're going to talk about the correlation that you would expect. What would happen between these data sets? So let me go through number one. In number one, it says, what happens when the number of hours you work versus the amount of money in your bank account? So let's do an example. What if you work no hours? What happens to your bank account? No, we're not talking about spending the money. Exactly. So no hours means that the money is going to stay the same. Oh, where do I have this? Okay, so I'm going to rewrite that so that I have enough space. So no hours would mean the money in the bank stays the same. And I can't spell money. Money. Let me get rid of all of that stuff. Stays the same. Hopefully we remember that the money is in the bank, okay? What if you work only a few hours?
Your money real thing slightly increases.
Yeah, the money increases slightly, right? Money increases slowly, slightly. All right. Remember, we're interpreting the data and we're predicting now. We're predicting what we think we're going to see in the data. Okay. What if you work lots of hours, many hours? All right, so what happens to the money in your bank account? What does that mean? Say the word, don't just use your hands. Increases slowly, slightly as well? Rapidly, there we go. All right, and the money accumulates faster. All right, we're assuming we're not spending it, right? So it is accumulating. Yes. No. All right, so can you, reading the next one, the number of hours that you receive, the number of hours that your workers receive safety training, and the number of accidents on the job. So let's talk about the number of hours that your workers receive safety training. What if you give them no hours of safety training? Well, once again, we're not predicting what the result of money. We're predicting the number of hours that your workers get safety training and what will happen to the number of accidents on the job. It might stay the same or it might go up like you guys are saying, right? So might stay the same. All right, semicolon, it might go up. All right, because if you don't remind people about what they should or should not do, they might make more mistakes on the job site, okay? Now, what if you give them only a few hours? What do you think would happen to the number of accidents on the job? Might decrease? What do you guys think? What if you only offer training, let's say, twice a year? Mandatory training where you have to sit there and listen to somebody tell you about the safety stuff. Like all the wonderful meetings that teachers go to. We would hope that we would have a slight decrease, right? That's what we want to predict. So yeah, a slight decrease in the number of accidents. All right, and what if you send them to training once a week, every single week, telling them all the safety procedures on the job? What increases? Thank you. Sorry, I heard it wrong. So a strong decrease, right? A strong decrease in the number of accidents. So now let's look at A. What type of correlation is A? Positive or negative? For A.
I want to say positive.
Okay. Elaborate. Why are you choosing positive?
That's the first thing that came to my head.
No, but we need a reason for choosing positive. What is it? Negative. Why are you saying negative? What's spread apart? Well, we're talking about the number of hours you work versus the money in your bank account, okay? This A, not the tables, not the graphs, I mean. So what type of correlation do you think the number of hours you work versus the amount of money in your bank account has? Positive correlation, negative correlation? Yes, as the hours increases, right? What happens to the money in your bank? So it's a positive correlation. Right? What is the correlation between the number of hours that you receive safety training versus the number of accidents on the job? What is the correlation? All right, so this is training hours. What happens to the number of accidents? Exactly. So in this case, you have a negative correlation. All right. So notice how I'm bringing in what we covered before. We have context, we're interpreting, we're predicting, and we're identifying. Okay. All right. This one, what are we comparing? We're comparing the number of students at Hillgrove and the number of dogs in Atlanta. Am I assuming that Hillgrove is a neighborhood in Atlanta?
I think so.
Okay. So the number of students at Hillgrove versus, wait a minute. I have a feeling that Hillgrove is their high school. So we're going to use Dutchtown here, okay?
That's in Springs, Georgia.
Shh. Yes, the number of students at Dutchtown. Well, I think that's the point of the question. All right, what is the relationship between the number of students at Dutchtown and the number of dogs in Atlanta? What if we have no students? All right, so how does that affect the number of dogs in Atlanta? What if we only have a few students? How does that affect the number of dogs in Atlanta? What if Dutchtown High School has many, many, many students? How does that affect the number of dogs in Atlanta?
They still got more than us.
Yeah.
No, they keep producing, you feel me?
We're not talking about, okay. So I think the conclusion that we should make here is that the number of students here in Hampton has nothing to do with the number of dogs in Atlanta because they're two completely different locations. Are we clear? So there is no correlation between it. You can't say that just because Dutchtown High School has more students, that somehow caused an increase of dog ownership in Atlanta. Okay, so there is no correlation. It doesn't make sense that the number of our students would affect who owns a dog in Atlanta. But once again, we're predicting. We're predicting, and I would predict that there is no correlation, okay? Okay. All right, let's look at the next situation. What do we predict between the number of heaters that were sold versus the months in order from April to September? Would there be a correlation between how many heaters are sold and during the months of April, May, June, July, August, September? So what do you think? Is there a relationship between how many heaters you're going to sell at your store in those months? You think that there's no relationship? Uh, because it's spring and summer, so it's warmer, right? You're saying? So that's correct. That during those months it's going to be warmer, right? Are you going to be needing a heater? Huh? Well, exactly. So you wouldn't need to go out and purchase a heater during those months because you wouldn't need it. Okay. So is there a correlation or no correlation? There is a correlation.
Yeah, I'm gonna say that.
Because the number of heaters sold stays pretty constant during those months, right? And the temperatures affect how many heaters you sell. The minute the temperatures go down, the number of heaters should go. Exactly, right? So yes, there is a correlation. There is a direct correlation, positive. But during these months, it wouldn't be positive, it would be constant. So it would be a constant correlation. Because it would stay at the same level. It would pretty much stay like this. But a horizontal line is still a line. Clear? Basically, the slope would be 0. But you know what? 0 slope is still a slope. That's a horizontal line. All right, what do you predict will happen to the number of rice dishes that you eat versus the number of cars on I-75 throughout the day? All right, so the number of rice that you eat, the number of rice dishes that you eat versus how many cars you have on the highway. No, we're not comparing quantity. We're asking, is there a relationship between those two data sets? Yes, there is no relationship, no correlation. All right. The last one, the number of calories that we burn, that means the number of calories that we lose, right? We're burning, we're losing them, versus the amount of hours that you work out. Do you think there's a correlation between those two? How many calories you burn and how many hours you work out? Is there a relationship? Is there a correlation? Yes? Okay, what type of relationship is there? Positive or negative? The more you work out,
The less weight or the less weight to lose.
so the more you burn, right? So it's a negative correlation. It's still, right? Because think about it, you're working out and what's happening? Exactly. So it's a negative correlation. Negative correlation is not bad. It's still a correlation. It just means that the thing that you're comparing it to is actually going down versus increasing in size. So negative doesn't mean bad.
The trend is monkey, right?
Okay. Now, we'll leave this one for next time because there's a difference between two things having a correlation and those two things actually causing one another. Clear? So, for example, I'm only thinking causation right now. But we'll look at different things like that they might both be increasing, but they have nothing to do with one another, right? Sort of thing. And that would be the difference between just being a correlation and actually causing that type of thing, right? But anyways, that's a discussion for tomorrow. This is enough. Are there any questions on identifying the correlation, interpreting the correlation, and predicting the correlation? No questions? All right, then I'm going to end this.